All right, we're diving straight into one of the biggest questions in tech today. AI can do some absolutely incredible things, but it's missing something. Something that stops it from really understanding the world the way we do. In this explainer, we're going to explore that exact missing link, a concept that might just be the key to unlocking true artificial general intelligence. And that brings us right to this central paradox, this huge mystery at the heart of modern AI. How can a system be so brilliant, superhuman in some ways, and yet so fragile and honestly kind of clueless in others? It's this brilliant but brittle thing that we really need to unpack. I mean, the contrast here is just wild. An AI can crush the world's best Go player, a game with more moves than atoms in the universe, and yet that same superintelligence can totally fail if you show it a slightly weird-looking chair. It can write flawless, complex code, but it lacks the basic common sense that a toddler uses every single day. So what on earth is going on here? Well, the answer, according to a whole lot of researchers, actually comes from philosophy. It's an idea called a universal. This is the missing link we're looking for, the concept that could finally unlock that flexible, adaptable, human-like intelligence we've been chasing. So what is a universal? It's actually a pretty simple idea. It's just a general quality that applies to a bunch of different individual things. Think about redness. A fire truck is red, an apple is red, a stop sign is red. They're all totally different objects, right? But they all share that universal property of being red. Same thing for circularity. A coin, a pizza, a planet, they all share it. It's the core idea, totally separate from any one example. And how do our brains get to these universals? Well, we use this little mental superpower called abstraction. It's the magic trick we all do without even thinking about it. It's our ability to look at that fire truck, that apple, and that stop sign, and just pull out the core idea of redness while ignoring all the other details, like size, shape, or what it's used for. Abstraction is how we find the signal, the universal, in all the noise of the real world. So here's the crucial point. This is where it all comes together. Many experts believe that these two ideas, universals and abstraction, aren't just some fuzzy philosophical concepts. No, they are the fundamental missing architectural pillars we absolutely need to build a true artificial general intelligence. They are the solution to that whole brilliant but brittle problem. Okay, so let's get practical. How does this old philosophical idea actually solve the real-world engineering problems that are holding AI back? How do we go from theory to actually building something better? This gets right to the heart of the brittleness problem. See, today's AI is an incredible memorizer. It can look at millions of photos of chairs and memorize the statistical patterns of pixels. But what it doesn't do is grasp the universal concept of chairness, the core idea of a surface that's designed for a person to sit on. An AGI built on abstraction wouldn't just be memorizing pictures, it would understand the fundamental, unchanging structure of what a chair is. And that would let it recognize any chair, no matter how bizarre it looks. And this leads to something incredible, something that's kind of the holy grail for AI researchers: one-shot learning. Think about it. You can show a kid a single, strange-looking gadget and say, hey, this is a widget. That child immediately abstracts the core features, what makes it a widget, and can then spot other widgets, even if they look pretty different. They don't need to see 10,000 examples. That right there is the power of abstraction, and it's something today's AI is desperate for. So how would we actually build this? Well, one of the most promising ideas out there is something called neurosymbolic AI. It's basically a hybrid system, a team-up. First, you have the neural network. It's great at pattern recognition. It looks at the messy, chaotic world and pulls out the core concepts, the universals, like red and cube. Then, a symbolic engine takes over. This part is pure, old-school logic. It applies reliable, straightforward rules to those concepts. If the object is a red cube, then put it in box A. You get the best of both worlds: fuzzy perception and rock-solid logic. And the difference this makes in understanding is, well, it's night and day. A large language model today knows that the word pain often shows up near the word doctor just because it's seen that pattern billions of times in text. It's a statistical correlation, that's it. But a true AGI would ground that symbol in reality. It would understand that pain is a universal biological state, a real-world feeling. That's the huge leap from just matching patterns to genuine comprehension. Okay, but here's where it gets really cool: transfer learning.
Without abstraction, learning to play chess and learning business negotiation are two completely separate, isolated tasks. But with abstraction, an AI can identify a universal pattern, like strategic defense, in chess, and then apply that abstract concept to a totally different field, like a business negotiation or even a military simulation. This ability to see the connections and transfer knowledge is the very definition of general intelligence. This table really sums it all up perfectly. We're talking about a fundamental shift. We're moving from statistical memorization to real conceptual abstraction, from needing absolutely massive data sets to learning from just a few examples, from brittle systems that break on weird edge cases to robust ones that can adapt. And most importantly, from siloed skills that are stuck in one place to knowledge that can be transferred anywhere. That's the future we're aiming for.
But this isn't just a technical problem we're trying to solve. The implications of abstraction go way beyond just writing better code. They get into the really deep and important territory of meaning, safety, and ethics. And this is absolutely critical for AI's safety. Think about it. If you give a super smart AI a giant rulebook of what not to do, it will always find a loophole. The much safer way to go is to build an AGI that operates on abstract, universal ethical principles. So instead of a million rules, it understands a core concept like fairness or minimizing harm. By reasoning from these deep principles, it can navigate tricky moral situations way more safely than a system that's just blindly following a list.
All right, so let's quickly recap what we've covered and then look at the next big question that's waiting for us on the horizon. We started with this central mystery of AI, how it can be so brilliant and so brittle at the same time. And we've journeyed all the way to a potential solution. This really elegant and powerful idea that by teaching machines to find the universal concepts in the world through abstraction, we can finally build a truly general and flexible intelligence. And that leaves us with one final fascinating question. It's the big one. How are the labs and engineers out there actually trying to code abstraction into machines right now? What do these new neurosymbolic systems really look like in practice? Well, that's the next frontier in the whole quest for AGI.